everyone, welcome to my class. I am your Sensei, and today we're going to discuss about the derivatives and slope. So our outline for today includes definition of the derivative, differentiation formulas, product rule, and of course, the quotient rule. Now for the definition of the derivative, so the derivative of f of x with respect to x is the function f prime of x, and it's defined as f prime of x equal to the limit of f of x plus h minus f of x over h as h approaches 0. Now let's apply that definition to this example. So example number 1, find the derivative of the following function using the definition of the derivative given f of x equal to 2x squared minus 16x plus 35. Okay. So from our definition a while ago, so we have f prime of x is equal to limit of f of x plus h minus f of x over h, then as h approaches 0. Now let us just substitute our given. So for f of x plus h, all our x in the equation will be substituted by x plus h. Okay. So limit of 2 times x plus h squared minus 16 times x plus h plus 35. Then minus our f of x, that is the original equation. So minus 2x squared minus 16x plus 35. All over h as h approaches 0. Ayan. So we have 2 x plus h squared, that is x squared plus 2xh plus h squared. Then distribute 16, negative 16x minus 16h plus 35. Then distribute the negative sign. Okay, 16x minus 35. Then all over h. Now let us try to simplify. So this will be 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35 minus 2x squared plus 16x minus 35. Okay, so what's next? So we can cancel out the 2x squared, the 16x, the 35. Ayan. Then we'll put the remaining terms here. We have 4xh plus 2h squared minus 16h. Okay, all over h, that will be 4x plus 2h minus 16. Then, applying the limit, h approaches 0. So this will be 0 because 2 times 0 is 0. Therefore, our answer would be 4x minus 16. Yeah, so that is the derivative of our given function. Example number 2, so find the derivative of the following function. Again, using the definition of the derivative, g of t is equal to t over t plus 1. Let's solve it here. So f prime of x, or that is g prime of t in our example, because our variables here is letter t, but it's just the same. So this will be limit of g of t plus h minus g of t all over h as h approaches 0. Now let us substitute our given. So for t plus g of t plus h, we'll substitute t plus h for all the t in the given. So we have limit of t plus h over t plus h plus 1 minus our g of t, that is the original equation, t over t plus 1. Then all over h as h approaches 0. Now we'll have to combine this fraction on the numerator. Let's rewrite this first. Then the LCD is t plus h plus 1 times t plus 1. Okay, this will be t plus h plus 1, t plus 1. Then this will be t plus h times t plus 1. Then this will be t times t plus h plus 1. Ayan. So let's simplify. Limit of so t plus h times t plus 1. So we will have t squared plus ht plus t plus h minus t squared minus th minus t all over the denominator h. I will put in the numerator, so that will be h times t plus h plus 1 times t plus 1. Ayan. Then let us check our equation. As you can see, we can cancel out the t squared, the ht, okay, and the t. Okay, so we have h only. We have remaining limit of h, but this can be cancelled out because we have h here. We can have 1. So let's write 1 over t plus h plus 1, then t plus 1 as h approaches 0. Then applying the limit as h approaches 0, so this will be 0. So therefore, we will have the answer as 1 all over t plus 1 squared. Ayan. So this is our final answer. So next example, find the derivative of the following function using the definition of the derivative. R of z is equal to the square root of 5z minus 8. Okay, so let's solve it here. So our formula will be r prime of z is equal to the limit of r of z plus h minus r of z all over h as h approaches 0. Now let's substitute. So all z in our equation will be z plus h here. So we have limit of the square root of 5 times z plus h minus 8 minus our r of z, that is the original equation, square root of 5z minus h. Then all over h as h approaches 0. Okay? Now, what to do here? Since we have here a radical expression, we can multiply both numerator and the denominator by its conjugate. Okay, so let's multiply by the conjugate of the numerator. So that is square root of 5 times z plus h minus h plus, because this is minus, square root of 5z minus 8. Also in the denominator, five z minus 8. Ayan. And then, let us simplify. So limit of, since we have here a sum and difference, multiplication of sum and difference, so this will be 5 times z plus h minus 8 minus 5z minus 8. So the radical expression will be cancelled. Okay, then on the denominator, we have h multiplied by the square root of 5 times z plus h minus 8 plus square root of 5z minus 8. Now, simplifying, the numerator will have 5z plus 5h minus 8 minus 5z minus times negative 8, that will be positive 8. Okay, then rewriting the denominator, z plus h minus 8 plus square root ng 5z minus h. There you go. So, as you can see, we can cancel out 5z and the 8 and also the h. So we will have the remaining 5 in the numerator, and then the denominator, we have the square root of 5 times z plus h minus 8 and plus square root ng 5z minus 8. Then applying the limit, h approaches 0, so this will be 0, and this expression will be the same as 5z minus 8. So therefore, our answer will be equal to 5 all over 2 square root of 5z minus 8. Since square root of 5z plus 8 plus square root of 5z minus 8, that's equal to 2 square root of 5z minus 8. So that is the derivative. Then we have another definition about derivatives. So a function f of x is called differentiable at x is equal to a if f prime of x exists, and f of x is called differentiable on an interval if the derivative exists for each point in that interval. Then theorem, if f of x is differentiable at x is equal to a, then f of x is continuous at x is equal to a. So we have here a given point, x is equal to a, and we can test if it is continuous or not, if that if the function is differentiable at that point. Then interpretations of the derivative. So rate of change, the first interpretation of the derivative is this, the rate of change. So this was not the first problem that we look at in the limit chapter, but it is the most important interpretation of the derivative. So if f of x represents a quantity at any x, then the derivative f prime of a represents the instantaneous rate of change of f of x at x is equal to a. So we have here an example of rate of change. So suppose that the amount of water in a holding tank at t minutes is given by v of t is equal to 2t squared minus 16t plus 35. Determine each of the following. So letter A, is the volume of water in the tank increasing or decreasing at t is equal to 1 minute? Letter B, is the volume of water in the tank increasing or decreasing at t is equal to 5 minutes? And letter C, is the volume of water in the tank changing faster at t is equal to 1 or at t is equal to 5 minutes? And letter D, is the volume of water in the tank ever not changing? If so, when? Okay, so these are the questions that we're going to answer in this problem. So let us answer it here. Ayan, so that I will have enough space for my computation. So we have here given t squared minus 2t squared minus 16t plus 35. So just the same as what we have solved a while ago in our example number 1. Okay, so we have the derivative of this one, as you can remember, 2t squared minus 16t plus 35. The derivative is 4t minus 16. Now, if we will test, for example, in the letter A, is the volume of water in the tank increasing or decreasing at t is equal to 1 minute? So we'll just have to substitute 1 in t. So let's say at t is equal to 1. So f prime of t is equal to 4t minus 16. So this will be f prime of 1 is equal to 4 times 1 minus 16. And this will be equal to negative 12. Since we have here a negative sign, so that means our volume is decreasing. Okay? So of course, positive sign means increasing. Negative sign means decreasing. Okay? Then for letter B, is the volume of water in the tank increasing or decreasing at t is equal to 5 minutes? So at t is equal to 5 minutes, we'll just have to substitute t is equal to 5. So this will be 4 times 5 minus 16. And this is equal to 20 minus 16 or equal to 4. So therefore, this is increasing because we have a positive value. Then for letter C, is the volume of water in the tank changing faster at t is equal to 1 or at t is equal to 5? So we have negative 12 and 4. So if we will compare if it is changing faster, so we'll have to look at the value. So since 12 is greater than 4, okay, we will disregard first the sign. Okay, so 12 is greater than 4, so it means that the water or the volume of water, the volume of water in the tank, so let us complete our answer, in the tank changes faster at t is equal to 1. So it is decreasing at 12 meters per second or 12 cubic meters per second, maybe. Then for letter D, is the volume of water in the tank ever not changing? So to solve this, f prime of t is equal to 4t minus 16. We'll just have to equate this to 0 so that the change will be equal to 0. The volume at that point will not change. Okay, so this will be 4t is equal to 16, t is equal to 4. So therefore, at time t is equal to 4 minutes, the volume of the water will not change. So that's how you interpret the rate of change in the derivative. Next, another application or another interpretation of the derivative in terms of slope of tangent line. So the slope of the tangent line to f of x at x is equal to a is f prime of a. Therefore, the tangent line then is given by y is equal to f of a plus f prime of a times x minus a. So actually, this is just the same with the point slope form, right? That is y is equal to y sub 1 plus m times x minus x sub 1, because our f prime of a is also the slope in the equation. So this is just the point slope form. Point slope form. Ayan. Now let's apply that here. So find the tangent line to the following function at z is equal to 3. So r of z is equal to the square root of 5z minus 8. So as you can see, this is one of the equations that we have solved a while ago. And its derivative, r prime of z, is equal to 5 over 2 square root of 5z minus 8. Okay? So we will apply the equation of the tangent line y is equal to f of a plus f prime of a times x minus a. But since we have a given r of z as a function, this is r of a plus r prime of a. Okay, and our x is z, then minus a. So we need r of a and r prime of a. And our a is equal to 3. So we need r of 3. So we'll just only have to substitute the 3 in the z. So this is 5 times 3 minus 8. That is equal to 15 minus 8. That is square root of 7. Then for r prime of 3, so substitute lang 5 over 2 square root of 5 times 3 minus 8, or that is equal to 5 over 2 square root of 7. Now that we have r of 3 and r prime of 3, we can substitute this to our equation for tangent line. So our r of a, that is square root of 7, then plus 5 over 2 square root of 7, then z minus 3. Ayan. So this is our equation for the tangent line. Next interpretation about the velocity. So if the position of an object is given by f of t after t units of time, the velocity of the object at t is equal to a is given by f prime of a. So example, suppose that the position of an object after t hours is given by g of t is equal to t over t plus 1. Answer both of the following about this object. So is the object moving to the right or to the left after or at t is equal to 10 hours? And letter B, does the object ever stop moving? Okay, so this example again, we have already solved. So the derivative g prime of t is equal to 1 over t plus 1 squared. So you can actually check in the previous example. So this is our derivative. So to answer letter A, so is the object moving to the right or to the left at t is equal to 10 hours? So let us substitute at t is equal to 10. G prime of 10 is equal to 1 over 10 plus 1 squared. This 1 over 1 to 1 because 11 squared is 1 to 1. And we have a positive answer. Okay, so remember that if we have a positive answer, so it can mean that it's increasing or moving up or moving to the right. Okay, so this means that the object is moving to the right since our answer is positive. Now for letter B, does the object ever stop moving? So our G prime of t is equal to 1 over t plus 1 squared, it can only stop moving if we will equate this equation into 0. But if we will do that, Okay, if you will try to equate this equation to 0, so it cannot be, right? Because that will be 1 over t plus 1 squared is equal to 0. Or if we will try to have a trial and error for the values of t so that this equation will be equal to 0, we need t is equal to negative 1 here, but we don't have a negative value of time, right? So our answer for letter B is no. So the object will not ever stop moving because we don't have a negative time. Okay? So that's it. Now let's proceed with the differentiation formulas, properties. So f of x plus or minus g of x prime, so that is equal to f prime of x plus or minus g prime of x. So for example, we have binomial or a trinomial and we were asked to find the derivative, so we can derivative each term. Okay, then proceed with addition or subtraction. Yeah, so in other words, to differentiate a sum or a difference, all we need to do is differentiate the individual terms and then put them back together with the appropriate signs. Then for number 2, we have c f of x prime is equal to c f prime of x, or the derivative of c f of x equal to c d of f of with respect to x, as e is any number. So in other words, we can factor the c or the multiplicative constant out of the derivative if we need to. Then if we have f of x equal to c, then f prime of x equal to 0. So our c here is any constant, so the derivative of any constant is equal to 0. Then if f of x equal to x raised to n, then f prime of x equal to n, x raised to n minus 1. So this formula is sometimes called the power rule. Okay, so we have x raised to n, that is a variable raised to an exponent. So we will apply the power rule. So all we are doing here is bringing the original exponent down in front and multiplying and then subtracting 1 from the original exponent. So note as well that in order to use this formula, n must be a number. Okay, so our n here, so we have x raised to n. Our n here must be any number, and x is our variable x. It will be tempting some leaders to use the power rule. So for example, if we have x raised to 3, so all we have to do is to bring down the 3 in front of x and subtract 1 to our original exponent. So this will be 3, then x, then 3 minus 1, that is 2. So our derivative of x cubed is equal to 3x squared. Now let's apply the differentiation formulas here. So f of x equal to 15x raised to 100 minus 3x raised to 12 plus 5x minus 46. So the derivative of this one, so applying the differentiation formulas, we have here x raised to 100. So applying the power rule, so we will just bring down the 100, then multiply it by 15. So that is 1,500. Then x raised to 100 minus 1. So this will be x raised to 99 minus 3 times 12, that is 36. X raised to 12 minus 1, that is 11. Then since the exponent of x here is 1, so that is 1 times 5 is 5, and the x, okay, so if we have x, the exponent is 1, so if we will bring down the 1 here, so that will be 1, then multiplied by x, the exponent 1 minus 1 will be 0, and any number raised to 0 will be equal to 1. So therefore, our x here will be eliminated. Then derivative of a constant is equal to 0. So no need to put 0 here. So this is our derivative for our first example. 1,500 x raised to 99 minus 36 x raised to 11 plus 5. Then for letter B, the g prime of t, so yan, 2 times 6, that is 12, t raised to 5. Then this is negative, so 7 times negative 6 is negative 42. T raised to negative 6 minus 1 is negative 7. Yan. So you have to be careful with the sign of the exponent. Okay? And of course, also be careful with multiplying terms of opposite signs. Next number for letter C. So this will be y prime is equal to 24 z squared minus, so we have 1 over 3 z raised to 5 here, but we can put the z raised to 5 into the numerator. So this will be, let's put it here. So the z raised to 5 will be z raised to negative 5. Okay, because we put it in the numerator. And if we will derive this, so this will be negative 5. Z raised to negative 5 minus 1 is negative 6. Since we have 1/3 here, negative 1/3, so multiplied by negative 5, that will be positive 5 over 3. Z raised to negative 6, or we will put the z raised to 6 in the denominator. Okay, then this is 1 and 0 for a 23. Then for letter D, we have square root of x plus 9 cube root of x raised to 7 minus 2 over 5th root of x squared. So we have some radical expressions here. So let us have let us express these radical expressions first as exponent, as fraction. Okay, so square root of x, that is x raised to 1/2 plus 9 x raised to 7, then cube root. So this will be 9x raised to 7 over 3. Then this will be minus 2 x raised to negative 2 over 5. Yan, because we put the x raised to 2 or x squared in the numerator. Yan. Now that it is already in this form, we can have the t prime of x. So this will be 1/2 x raised to 1/2 minus 1 is negative 1/2 plus 9 times 7 over 3 x raised to 7 over 3 minus 1, that is 7 minus 3, 4 over 3, minus 2 times negative 2 over 5 x raised to negative 2/5 minus 1, or negative 2 minus 5, negative 7 over 5. Okay. So ako siya susulat. Our t prime of x, if we will simplify this, or we will bring it back to radical expression, this will be 1 over 2 square root of x plus 9 times 7 over 3, that will be 3 times 7, 21 x cube root of x raised to 4. Then 2 times 2/5, that is 4 over 5, 5th root of x raised to 7. Yan. So that is our final answer. Then for letter E, h prime of x. So we have here x of x raised to pi. So we'll put the pi in front, then x, then pi minus 1. So that's just simple as that. Then x raised to square root of 2. So again, we'll put the square root of 2 in front of x. Then the denominator will be subtracted by 1. Yeah. So that is the derivative. So next example, differentiate each of the following functions. So we have letter A, y is equal to the cube root of x squared times 2x minus x squared. So let us start here. So first, this radical expression, let's express as x raised to 2/3. Okay, then 2x minus x squared. Then let us distribute. Okay, so this will be x raised to 2/3 times 2x. That will be 2x times 2 plus 3. That is 5 over 3. Minus x raised to 2/3 plus 2. That is 6 plus 2, 8 over 3. So how do I do that? So 2/3. So if you have 2/3 plus 1, that is just the same as 2/3 plus 3 over 3, right? So I will just think of 1 as 3 over 3. So therefore 2 plus 3 is equal to 5 over 3. And for 2/3 plus 2, that is the same as 2/3 plus 6 over 3. Okay, that is equal to 6 over 3. So that's why I said a while ago 2 plus 6, that is 8, then over 3. So that is how you do mental calculation of summation of fractions. So now we can derive this. So this will be 2 times 5 over 3. X raised to 5 over 3 minus 1, or 5 minus 3. That is 2/3. Minus 8 over 3. X raised to 8 over 3 minus 1, or 8 minus 3. That is 5 over 3. So our final answer, y prime is equal to 10 over 3. X raised to 2/3 minus 8 over 3, x raised to 5 over 3. Ayan. So that is our answer. Now for letter B, we have h of t is equal to 2t raised to 5 plus t squared minus 5 all over t squared. So we can first simplify this one. So divide the numerator by t squared. So 2t raised to 3, because 5 minus 2 is 3. Then t squared divided by t squared is 1. Then 5 divided by t squared, that is 5t raised to negative 2. Then we'll proceed with the derivative. So h prime of t is equal to 6t squared. Then derivative of 1 is 0, so no need to write. Then negative 5t raised to negative 2. Derivative is equal to 5 times 2, that is positive 10. T raised to negative 2 minus 1 is negative 3. So this is our answer. Next is f of x equal to 2x cubed plus 300 over x cubed plus 4 increasing or decreasing or not changing at x equal to negative 2. So to answer this, we'll have to get the derivative. So this is f prime of x equal to 6x squared, because 2 times 3 is 6, then x squared, plus 300 over x cubed, that is the same as 300 x raised to negative 3. So this will be 300 times negative 3, x raised to negative 3 minus 1 is negative 4. Then derivative of 4 is 0. So therefore, our f prime of x is equal to 6x squared minus 900 over x raised to 4. Yan. Then at x is equal to negative 2, at x is equal to negative 2, so that is f prime of negative 2 is equal to 6 times negative 2 squared minus 900 over negative 2 raised to 4. So this is 6 times 4 minus 900 over 2 times negative 2 raised to 4, that is 16. So we have 24 minus 900 over 16. That is negative 32.25. So therefore, since we have a negative answer, so our answer here is decreasing. So at x is equal to negative 2, this function is decreasing. Example number 9, so find the equation of the tangent line to f of x equal to 4x minus 8 square root of x at x is equal to 16. So again, our equation of the tangent line, that is y is equal to f of a plus f prime of a times x minus a. So let's have the derivative of this function first. So f of x is equal to 4x minus 8x raised to 1 half. So square root of x is equal to x raised to 1 half. So the derivative f prime of x is equal to 4 minus 8 times 1 half x raised to negative 1 half. So this will be 4 minus 4 over square root of x. Then we need f of a or f of 16. Okay, so 4 times 16 minus 8 square root of 16. So this will be 64 minus 8 times 4. That is 64 minus 32 equal to 32. Then our f prime of 16 is equal to 4 minus 4 over square root of 16. So this will be 4 minus 4 over 4. This is 1, so this is equal to 3. So therefore, our equation is y is equal to, our f of a is 32 plus our f prime of a is 3, then x minus 16. So this is our equation of the tangent line. Yan. Then let's proceed with the product and quotient rule. So product rule, if the two functions f of x and g of x are differentiable or the derivative exists, then the product is differentiable and f multiplied by g, so prime is equal to f prime of f prime g plus f g prime. Okay. Then for the quotient rule, if the two functions f of x and g of x are differentiable, then the quotient is differentiable and f over g prime is equal to f prime g minus f g prime over g squared. This product rule, so I have different notation, like if we have derivative of ub, this u and v is just the same as fg. So we have u dv plus v du. Okay, so we just only have to write the function first, the u, then derivative of the other function, then plus v, then derivative of the other function, du. For a quotient rule, we have derivative of u over v. So we have v du minus u dv over v squared. So used to apply this formulas instead of f over g and fg. So it's up to you whether what notation will you use to apply the product and quotient rule. So the process is just the same. So you just only have to get this format. So u dv plus v du. Then for quotient rule, that is v du minus u dv over v squared. Okay, so let's apply the product and quotient rule in this example. So differentiate each of the following. Y is equal to cube root of x squared times 2x minus x squared. So this is the same as what we have solved a while ago. So let us check if we will get the same answer if we will apply the product rule. Okay, so let us express this as 2/3 2x minus x squared. So this will be your u and this will be your v or f and g. So let us apply u dv plus v du. Our u is x raised to 2/3. Then derivative of 2x minus x squared is 2 minus 2x. Then add v. So that is 2x minus x squared. Then derivative of x raised to 2/3 is 2/3 times x raised to negative 1/3. 2/3 minus 1 is negative 1/3. Ayan. So, simplifying, we'll have 2x raised to 2/3 minus 2x raised to 5 over 3. 2x times 2/3, that is 4/3. X raised to 3 minus 1, that is 2/3. Minus x squared times 2/3 x raised to negative 1/3, that is 6 minus 1, that is 5 over 3. Ayan. So we have 2 plus 4, that is 6 plus 4, 10 over 3, x raised to 2/3. Then negative 2 minus 2/3, that is negative 6 minus 2 or negative 8 over 3, x raised to 5 over 3. Now you can check the previous example if it's the same. It's the same, right? Ayan, so we can use product rule, or you can first distribute the x raised to 2/3 in the 2x minus x squared before deriving. So it's up to you. So the answer will just be the same. Then for letter B, we have f of x equal to 6x cubed minus x times 10 minus 20x. So this will be our u and this will be our v. Okay. So for u, let's write 6x cubed minus x. Then derivative of 10 minus 20x is negative 20. Then plus 10 minus 20x. Then derivative of 6x cubed minus x is 18x squared minus 1. And then we will simplify. So 6x cubed minus x times negative 20 is negative 120 x cubed plus 20x. Then this one, 10 times 18x squared, 180x squared. First, outer, negative 10. Inner, negative 360x cubed. And last, positive 20x. Okay. So, we will have negative 120 minus 360 is negative 480 x cubed plus 180x squared plus 40x, okay, minus 10. Ayan. So, that is our answer. Or another method of solving this is to distribute this, this binomial before you proceed with power rule. No? You can check if the answer is just the same. And so, next example, differentiate each of the following functions so using quotient rule. Okay, so let's solve it here. And so that I have enough space. Okay, so letter A, w of z is equal to 3z plus 9 over 2 minus z. Letter A. Ayan. So our w prime of z is equal to, so our derivative for u over b is equal to v du minus u dv over v squared. So v, that is 2 minus z du, or derivative of the u, that is 3, minus u, 3z plus 9. Derivative of the denominator is negative 1. Then v squared. 2 minus z squared. So this will be 6 minus 3z plus 3z plus 9 over 2 minus z squared. So this will be 15 because this will be cancelled, negative 3z. So we'll have 15 over 2 minus z raised to 2. For letter B, that is h of x is equal to 4 square root of x over x squared minus 2. So this is equal to 4x raised to 1 half over x squared minus 2. So h prime of x is equal to v du. Our v is x squared minus 2. X squared minus 2. Derivative of the numerator, that is 4 times 1 half is 2. X raised to negative 1 half minus u, that is 4x raised to 1 half. Then derivative of the denominator, that is 2x. All over x squared minus 2 squared. So this will be 2 x squared minus 2 times 2x raised to negative 1 half, that is 2x raised to 3 over 2 minus 4x raised to negative 1 half minus 8x raised to 3 over 2 all over x squared minus 2 squared. So 2 minus 8 is negative 6x raised to 3 halves minus 4x raised to negative 1 half over x squared minus 2 squared. Ayan. So that is our answer. Now for letter C, f of x is equal to 4 over x raised to 6, or okay, sige, we will apply the quotient rule here, but you can actually use the power rule. So just put the x raised to 6 in the numerator. This will be x raised to negative 6. Then proceed with the power rule. But since we are on the quotient rule, okay, fine. We will apply v du minus u du v. So our v is x raised to 6. Our derivative of numerator is 0 because it is constant. Minus u dv, so 4 times derivative of the denominator is 6x raised to 5. Then v squared, that is x raised to 6 squared. So f prime of x is equal to negative 24 x raised to 5 over x raised to 6 times 2 is 12. So therefore, this will be negative 24 over x raised to 7. Ayan. Now, if you will check for 4 over x raised to 6 is equal to 4x raised to negative 6. Applying power rule, this will be negative 24. X raised to negative 6 minus 1 is negative 7. Ayan. And it is the same as what we got using quotient rule. Then last item, y is equal to w6 over 5. So v, that is 5, du, derivative of numerator, 6w raised to 5, minus u, w raised to 6, dv is 0, over v squared is 5 squared. So we have 30, w raised to 5, then this will be 0, and over 25. Or also equal to 6 over 5, w raised to 5. Ayan. So again, you can apply, if this is the case, you can just only apply the power rule. That's it. Okay, so example number 12, suppose that the amount of air in a balloon at any time t is given by v of t is equal to 6 cube root of t over 4t plus 1. So determine if the balloon is being filled with air or being drained of air at t is equal to 8. Okay. Okay, so this equation, let us express this first as 6t raised to 1/3 over 4t plus 1. Ayan. Then, let's apply v du minus u dv or the quotient rule. So, v, that is 4t plus 1. Derivative of numerator, that is 6 times 1/3. T raised to negative 2/3 minus u, 6t raised to 1/3 du, dv, derivative of the denominator, that is 4, all over 4t plus 1 squared. Now let us simplify. 6 times 1/3, that is 2. T raised to negative 2/3 minus, this is 24. T raised to 1/3 over 4t plus 1 squared. So, 4t plus 1 times 2, t raised to negative 2/3, that is equal to 8t raised to 1/3 plus 2, t raised to negative 2/3 minus 24, t raised to 1/3, then all over 4t plus 1 squared. So, this is equal to negative 16, t raised to 1/3 plus 2t raised to negative 2/3 all over 4t plus 1 squared. Then at t is equal to 8, so let's substitute the value of t in our equation. So this will be v prime of t, or v prime of a, that is equal to negative 16 times 8 raised to 1/3 plus 2 times 8 raised to negative 2/3 all over 4 times 8 plus 1 squared. And this is equal to negative 7 over 242. And since our answer is negative, so therefore the volume of air is decreasing at T is equal to 8. Yan, lagay natin. Decreasing. So that is our answer. So for the summary, so let us recall all the topics that we have discussed so far. So the derivative of f of x with respect to x is the function f prime of x, and is defined as the limit of f of x plus h minus f of x over h as h approaches 0. Then a function f of x is called differentiable at x is equal to a if f prime of x exists, and f of x is called differentiable on an interval if the derivative exists for each point in that interval. Then third one, if f of x is differentiable at x is equal to a, then f of x is continuous at x is equal to a. Then we also discussed the slope of the tangent line to f of x at x equal to a. So the equation of the tangent line is given by y is equal to f of a plus f prime of a times x minus a. Then we have derivatives of sum and difference. So all we need to do is to differentiate the individual terms and then put them back together with the appropriate sign. So note as well that this property is not limited to two functions. So mathematically, we have f of x plus or minus g of x prime is equal to f prime of x plus or minus g prime of x. Then we can factor a multiplicative constant out of derivative if we need to. So if we have c f of x, the derivative is c f prime of x. Then the derivative of a constant is always 0. Then we also have the power rule. So if you have f of x is equal to x raised to n, so its derivative is n x raised to n minus 1. So you just only have to put the exponent in front of the x, then subtract 1 on the original exponent. Okay? Then for the product rule, so if the two functions f of x and g of x are differentiable, then the product is differentiable, and fg prime is equal to f prime g plus fg prime, or derivative of uv is equal to udv plus vdu. Then for quotient rule, so if the two functions f of x and g of x are differentiable, then the quotient is differentiable and is equal to f over g prime is equal to f prime g minus f g prime all over g squared. Okay? Or that is v du minus u dv over v squared. So that's the end of our discussion for today. I hope you have learned a lot about derivatives and slope. And don't forget to like and subscribe for more tutorial videos. Thank you.